So today we're going to talk about clouds. Last week we talked about wind and how when the earth heats up, it causes the air to heat up, and that makes it less dense, and it rises up, causing a high pressure system or a high pressure area, and then a low pressure area comes in. And usually with that, in that low pressure area, it's going to bring in a lot of cooler, moist air, and that's going to give you a lot of clouds. So first let's talk about how those clouds are formed. We talked a bit last week about how along with the nitrogen and oxygen and argon and carbon dioxide and helium and everything else that's in the atmosphere, there's also a varying degree of water molecules and gas form, water vapor that we have here. But they're usually pretty separated. They're they don't really stick well together because they do have such great energy and everything. So we need something called a nuclei. So what a nuclei is, it's a little speck. It can be dust or salt that's evaporated up with ocean water, volcanic dust, little bits of dirt, anything like that. And it's just something that the water can kind of grab onto and kind of make a link between these different water molecules. And they are actually things that are hygroscopic. Hygro is water, and then scopic, it's attracted to. And so what that means is as the water is going around it, it's going to kind of pull the water in. If it were on a larger scale, it would kind of absorb the water. It's kind of, things, when we think about things being hydrophobic, that would be like you think of when the water like rolls off a duck's back. So this is the opposite. It'd be the water just getting absorbed on a larger scale. So that's what that is. Now, the rain or the clouds or the precipitation, is built on these nuclei, but for the most part, these nuclei are so small that, the rain coming down or the precipitation that's coming down is still mostly just pure water. So it's not like, you've got a bucket of dirt that's being poured on you. What the rain and everything is still mostly water, and in clouds, it's still just mostly water. Now, temperature does play a big role in this. We'll stick there for now. So evaporation and condensation are words that hopefully you're pretty familiar with. Evaporation is when the water, basically it dries up. If you, spill water or something on the sidewalk in the summer and then, 15 minutes later it's gone. It's all evaporated. It is turned from a liquid into a gas and gone up into the atmosphere. Water will evaporate much more quickly if it is spread out. For example, if you just leave your water in the glass or in a pool or wherever, it's going to still be there 15 minutes later, but if you spill it, then it'll be gone. So that layer, all the layers of water, keep it from evaporating. It's only going to be evaporating from that top layer. So the more top layer there is, the faster water is going to evaporate. And again, as with any fluid, whenever it is hotter, like it is near the earth before it rises up into the atmosphere, there's going to be more space for molecules. The molecules have more energy, they're farther apart, they're bouncing around more, so they're just going to be going all over the place, going crazy. So this is something that happens at the surface mostly. It does happen at other layers because there's just so much energy in the atmosphere at a molecular level, but mostly it's going to be happening at the surface because we have the energy coming from the sun and also the energy coming from the earth as well as it bounces off and radiates back. So all of that water is going to evaporate from things drying off or getting exhaled out of plants and animals. Also the rivers and oceans and lakes and everything, we're going to have a bit of evaporation there. So then the water is going to rise up in the air, and as it rises, it's going to cool off. And then when it cools off, we're going to get condensation. So this is when it turns from a gas back into a liquid, and we get those little droplets, or that sweating that you'd see on the outside of a cold drink when it's warmer out. I don't know, I guess it pretty much happens all the time. So we get those droplets that start to form again. And this is going to happen higher up in the atmosphere because it is cold. It's colder, the energy is being, I guess, released, it's being used, and so the pressure or the volume that the air takes up is going to decrease, and the water molecules are going to start bumping into these nuclei, and they're going to start condensing into these droplets. Now the temperature that happens at is called the dew point. Okay, and hopefully this picture looks familiar. So the dew point is just the temperature that condensation happens. We have, and that's going to depend on a lot of things, such as the types of nuclei that are in the air, the amount of humidity there is, which is just the amount of water vapor that's in the air, and just a lot of things. So that changes from day to day. It's not a fixed set number like, you know, we have the freezing point of water is 0 degrees Celsius and the boiling point is 100 degrees. There isn't a set fixed dew point. It's determined by a lot of different factors. But in this example from your reading, they've decided that our dew point is 65 degrees. Now, when the air, this chunk of air, is at the surface, it's 87 degrees, so the water is still going to stay gaseous. And also you see how small this box is. Okay, so it's nice and hot, so it's going to start to rise. As it rises, it's going to expand. As it expands, the temperature is going down, but we're still above the dew point, so the water is staying in a vapor form. And so, since it's still pretty warm, that air is going to continue to rise, and now our temperature has reached the dew point, and so now that water is going to get grabbed by those hydroscopic nuclei and start forming those clouds. And these numbers, the 4,000 feet, the 2,000 feet, those again dependent on the particulars of the day, how much water vapor is in the air, what the temperature is, where the wind is coming from and going to, all those things. So these are just examples of numbers. But that dew point is where that cloud is going to form. So speaking of clouds, there are 4 main types of clouds. And these are just little pictures to help you kind of visualize it. There are, the first one is the cirriform, and it actually comes from the Latin word meaning curls, and these are just going to look like little wisps. They don't really look like anything in particular. They're just kind of there, and they're usually, we'll talk about it more in a minute, but they're usually fairly high, and they're usually made out of ice crystals. So it's kind of like, you know, there's the different kinds of snow. There's like the very wet snow that's really good for like snowmen and snowballs and things like that, and then there's that very, very fine, hard snow that's, if you live somewhere that's really high up or really cold, and it's even like there's the fresh powder, and that's nice, but this is even like a harder, more crystalline snow. That's the kind of cloud we're talking about. Not that cirrus clouds or cirriform clouds form snow, but it's just those nice little crystals because generally they are so high. And these usually come before a low pressure system. Now, a lot of the times low pressure systems bring in a lot of, you know, moist air, and so there can be a lot of storms and things associated with low pressure systems, but that is not always the case. But low pressure systems do affect things other ways. So even if there isn't precipitation coming with this low pressure form, when you see those cirroform clouds, you know that something's going to come, even if it's just, like windstorms. Okay, probably the most popular kind of cloud, at least with little kids, would be the cumuloform clouds. And those are the big fluffy cotton ball clouds. They have nice defined edges. They're the ones that you lay on your back and you decide that it looks like a rabbit or a house or, whatever. These clouds there are actually 10 kinds of clouds, and we'll talk about that in a minute. But these cumuloform clouds can exist in a lot of different heights, and they show the vertical thermal movement. So they can get very, very tall, and they can extend from, we'll talk about the stratocumulo clouds or cumulostratus clouds, and that are at the very bottom all the way to the cirrocumulus clouds. So they can extend throughout the entire troposphere, and you can really see how high or how great a distance that energy, that thermal energy, is traveling through. Okay, there's also stratiform clouds, and they just are, strato comes from the Latin word for layer, and so these are just going to have a nice blanket over everything, and they're usually fairly low. And they form with non-convection rising air, so we don't have the hot air rising and then immediately getting replaced by cooler air. So it's just kind of everything just goes up and just kind of stays there. Here in near Albany, New York, we have a lot of very gray days where it's just cloudy, and the whole sky is covered and it's just full of clouds, and it's just kind of bleh. So that is the loveliness that I get to deal with, and hopefully you don't either. That you don't also have to deal with that. And then, of course, we have the nimboform clouds, and the nimboforms really can be, well, they can mostly be the cumuloform or the stratoform. There aren't too many nimbocirrus clouds, but these are just rain clouds. So you definitely get that dark black, rain color. And yeah, it's a combination of other clouds. It's just a different distinction between the nice, happy, fluffy, white cumulo clouds and a big thundercloud. Okay, so now in those 4 core kinds of clouds, there are 10 different distinctions. All right, and okay, so the first kind we talked about a bit before are these cirrus clouds, and they're just nice and wispy and very high up and just made of those little ice crystals that are just kind of blowing through the atmosphere, not doing a whole lot, but coming in before a low pressure system. Okay, and then we have the cirrocumulus clouds. Okay, so again, showing some of that vertical movement, a bit more accumulated, a bit more together than just plain cirrus clouds, but still, very, very high up there. We have the cirrostratus clouds up here. See that nice layer, but again, very high. All of these clouds made from just those ice crystals, but depending on how the crystals are made, we get the different looks. Okay, so now in this alto, in this alto category, we have kind of the mid-level clouds. All right, and the alto, just like in music, talks about this middle level. It also is just to serve as a distinction, because we have alto cumulus, alto stratus. It's a distinction between just the cumulus and the stratus. These are going to be kind of medium clouds. When we have the high clouds, we've got, again, a lot of ice crystals. When we have these low clouds, we have very, very wet clouds. And these alto clouds, they're just kind of in the middle except for these nimbostratus clouds. Okay. So here we've got these altostratus and the altocumulus. Again, nice layers here. We're getting a little bit fluffier, but not quite the cotton ball look that we're used to. Okay, and then we come down to the low-level clouds, and we have here we get our nice pretty picture cumulus clouds. Very good and happy. We get our stratocumulus clouds that still have the layers, but are, they've got a bit of fluff to them. We have just plain stratus clouds, very low, very gray, nice and foggy. Basically a foggy day. We get those stratus clouds. Then we've got the cumulonimbus, big rain clouds, and then we get that anvil effect. Also that anvil effect on the nimbostratus clouds. And that anvil effect we talked a bit about last time. As we get out of, this is all happening in the troposphere. When we get out of that troposphere, hit the tropopause, and then get into the stratosphere above. Okay, so again, so we've got the cirrus clouds, cirriform clouds, very high, lots of ice, alto clouds, middle level clouds. The nimbostratus is also a mid-level cloud. The cumulus, stratocumulus, and stratus are those low-level clouds, and then the cumulonimbus is this big giant one that we've got a lot of room to make rain or snow or other kinds of precipitation.